Okay, so in our last video, we were talking about, sorry, I'm trying to get this to cooperate. We were talking about this methanol mixture problem, and I'd gotten to the point where I was discussing the total amount of methanol contributed, I'm sorry, total pure methanol contributed by each solution. And sometimes people have a bit of a hard time visualizing this, so I'm going to draw a crude picture of what we have. Okay, so this is 4% plus the 14% equals the final. Now we know that in the final we want to get, I think it was 50 gallons of 14%, I'm sorry, 7%. So this total, let me put this in blue, total is 50 gallons. Okay. Now, that's not the amount of actual 100% methanol, right? How much actual pure methanol there is, that's like, let's say that's all down here at the bottom. Okay. And now how many gallons of this is pure methanol? Well, it would be 0.14, I'm sorry, I keep messing up that percentage. That's 7%, so that's 0.07 times 50, which is, and I'm just doing this just to get you comfortable with the idea. So this is 3.5 gallons. 3.5 gallons of pure 100% methanol is what we are going to end up with. And I got that by multiplying the percentage times the total. So that exact same idea is true over here. Over here I've got some total amount, and that total amount is X. And here I've got some total amount, and that total amount is Y. And then down here in green, I've got my pure stuff, and then down here in green I've got my pure stuff, and the exact same computation that I used over here I'm going to use here to figure out my pure amounts, except that I don't know all the numbers. So this one is 4%, so that's going to be 0.04 times X, X being the number of total gallons, and this is going to be 0.14 times Y, and that has got to add up to be, we already know this is 3.5, but I'll just write it like this, 0.07 times 50. And this is my pure methanol equation down here at the bottom. Now I could just write that as 3.5, but that's the full equation. Oh, and I'm sorry, and I also need a plus because we're just pouring one into the other, right? So that's just additive. Okay, so that's a little explanation of this second part of the system. And so my full system is going to be X plus Y equals 50. That's for equation 1. And equation 2 is 0.04X plus 0.14Y equals 0.07 times 50. Or you can just write that as 3.5, whichever you like. And so this is our 2x2 system. So our matrix is going to be 1, 1, 0.04, 0.14, inverse, and then I'm going to multiply that by 50.07. Now I'm being kind of lazy here, but this is going to be my final computation, and this will give me my matrix. This will give me my answer. When I compute this, it's going to come out to be my values that for the 4% and the 14%. That'll give me the, I don't know why that's still there. That'll give me the answer that I want. Okay. Okay, so all that being said, here's the slide that discusses this. So as I was talking about the pure methanol, if it's 4% methanol, it contains 0.04x gallons of methanol. And then if it's 14%, then it contains 0.14y, so on and so forth, and we end up with this system. So here's our 2x2 full system. I didn't actually write this out with in this form. I went ahead and wrote it out in my multiplied form. Right, there's the multiplied form, but that's the system. And then we're going to enter this first matrix as our matrix A. This would be our matrix B, and then we'll do A inverse times B. Okay, that's a 2x2 matrix and a 2x1 matrix. And as before, you should get a product, A inverse times B, and your solution is 35, 15, where 35 is X and 15 is Y. This is 35 gallons of 4%, and this is 15 gallons of 14%. All right. And if we combine the two solutions in these proportions, we will get 50 gallons of 7% methanol. All right, let's look at another example. You have $48 to spend on refreshments for a party. A large bag of chips costs $3 and drinks cost $1. You need to buy 5 times as many drinks as bags of chips. Here's the question. How many bags of chips and how many drinks can you buy? So we have our main question, and from our main question we're going to get our variables. So the first one is going to be, I'm going to call that C for number of bags of chips, and D for number of drinks. So that is those are the things that we are looking for. Now this problem is a little bit different because I'm given a different type of information. So I don't have a total amount equation that I can write. I can't write C plus D equals anything, right? If I wrote C plus D equaled something, that would be adding it. That would just be all the bags of chips and all the drinks, and then that would be like my total number of stuff, but I don't have any information on that. What I do have, a total information statement that I have is this. I have $48 total that I can spend. So, and I have cost information. So if a bag of chips costs $3 and a drink costs $1, then my total cost is going to be my chip cost plus my drink cost, and that equals $48, right? So my chip cost is the cost per bag times the number of bags. So the number of bags is C, and the cost per bag is 3. My drink cost is going to be the number of drinks times the cost of a drink, which is $1. So that's going to be 1 times D, and that equals 48. So that sum equals 48. So there you go. There is one equation. But we need another one. There's an operating principle here that I think we need to also make clear, which is that I need to have as many equations as I have variables. And I'm not sure I've ever explicitly said that, but I need as many equations as variables. So if I have 2 variables, C and D, I need 2 equations to solve for those. Okay. All right, so there's one equation, so I need another equation. What other piece of information do I have? Well, it's right here. So you need to buy 5 times as many drinks as bags of chips. So we need to take this statement and turn it into a equation. And this tends to confuse people. I think a lot of times people write this down in the wrong order. So let's closely stare at this and read it and think about it. I need to have 5 times as many drinks as bags of chips. Okay. So what's the relationship between the number of drinks and the number of bags of chips? So we've got something. It's not something needs to go here or something needs to go here. So we have to decide what goes where. So if I say 5 times as many drinks as bags of chips, that means that if I multiply the number of bags of chips times 5, that will equal the number of drinks that I have. So this is where people always can get confused. I think I see a lot of people put the 5 over here. But just think about this statement. Number of drinks has got to equal 5 times the number of bags of chips. If you get confused about this, think about which of these has got to be the smaller number. So if I'm going to buy 5 times as many drinks, the number of drinks is going to be much larger than the number of bags of chips. So the number of D is going to be much larger than the number C. Okay, and so that kind of points you in a direction of which one of these you need to make bigger, and the one that we need to make bigger to have equality is the C one. So that one's the one that needs to get multiplied by 5. And I think this just takes a little practice. But anyway, there's our equation. Now, the other weird thing about this equation as it's written at the moment is it doesn't look anything like this. And if you remember when we talked about matrices, I was very careful to talk about how you had to make sure that it was in the proper normal form and in the right order and everything. This is not in normal form or in the right order. So I need to move these things around. So the first thing that I'm going to do is I want it to look exactly like this. I mean, not exactly with the numbers, but in the form. I want the C first, then the D, and then the number. Or we could have done the D first, and then the C, and then the number. But either way, we have to be consistent. So if I move, the first thing I'm going to do is move this to the other side. And so that would give me, it's an arrow, D minus 5C equals 0. That's pretty close, except now I just need to reverse these two. And so I'm going to put this one first, and so that would be minus 5C plus D equals 0. And yes, it's just a 0 there. So that's the final equation. If we're going to do the C first, I noticed in this solution that I've actually got the D first. So it doesn't really matter. So if we're going to do the D first, then I would have left this one alone and I would have flipped this one around. So that one would have been D plus 3C equals 48. And this one would stay. I guess that's maybe a little better because then I don't have to worry about the negative. Either way, our final system is going to be comprised of this equation and this equation. Another thing I should point out, I was noticing here in the difference between the typed solution and my handwritten solution is that well, let me just show you. I solved my equation. I set my equation up with the D on the left-hand side, whereas this has the D on the right-hand side, and so that superficially it looks a little different because I have the negative D, whereas I have negative C. But actually, these two equations are saying the exact same thing, so I don't want that to throw you. It's the only difference is whether you wrote 5C equals D or D equals 5C. Either one of those is totally valid, and then we solve for 0 and move ahead. Our matrices in the end will be the same, and we would get the same answers. Okay, so moving ahead, let's say that we, I guess why don't we just go with this solution that's typed up here. So we'll all use this form. So our first equation is D plus 3C and then minus D plus 5C. That comes from moving this to the other side. And our matrix would be 1, 3.